This lesson is going to look at integrals of logarithms and exponential functions. I'm going to break this video up into two parts. The first one will look at the logarithms, the second will look at the exponential functions, but we put them together since they are inverse functions of each other. So if you recall from the derivatives, when we had the derivative of the natural log was 1 over whatever was inside, we're going to go backwards from that, of course, to find the integral. So the integral of 1 over x or 1 over u du is going to give us the natural log. The difference here is we're going to look at the absolute value because we cannot take the natural log of a negative number. So we're going to focus on that first, and then we'll come over here and we'll talk about the integral of e to the u du is of course e to the u plus c because again derivative of e to the x is e to the x. So looking at these tend to be some of the trickier integrals just because people want to try to rewrite them and use the power rule, and that's not going to work. If you were to do that, just to kind of show you, if we were going to rewrite it, we'd have the integral of 3x plus 2 to the negative 1 dx. And again, we're going to have to use u substitution because we have this inside function. So u is 3x plus 2. Derivative of u is just 3 dx. So we've got our dx here, but we don't have a 3, so we will change this to being 1/3 of du is dx. And if you go through and rewrite that, you get the integral of u to the negative 1, and then you've got your 1/3 and your du. And again, if you try to use the power rule here, you would see that you have, to increase this negative 1, you'd get 0. So you'd have an exponent of 0, which is fine. It just means anything to the 0 power is 1. But when you divide by that 0, that ends up giving you division by 0, which is undefined. So it doesn't work. So this is where that natural log comes into play. Instead, it's just easier to write it as the integral of 1/3 of 1 over u du, or du over u, which integrates to be 1/3 natural log absolute value of u plus c, and then we substitute the u back in, so we end up with 1/3 natural log of 3x plus 2 plus c. Next one here, again, u is going to be our denominator here. Again, we can tell because it's got the higher exponent, because it's in the denominator. We're going to take that whole thing, x to the 4th minus 1. We're not going to take the negative 1 exponent with it though. Du is going to be 4x cubed. Again, derivative of 1 is just 0. Dx, again, we've got an x cubed dx, so we've got part of it, but we don't have the 4, so we will just make this 1/4 of du is x cubed dx. Again, we're taking the derivative of x, so we have dx. And then we're kind of plugging this all in, substituting, we end up with this part up here is our 1/4 du that we substitute in for the x cubed dx, and then we put that over our just u because that was the x to the 4th minus 1. And so now our integral is going to end up being our 1/4, and then the integral of du over u we said is natural log absolute value of u plus c. So substituting back in, we get 1/4 natural log absolute value of our x to the 4th minus 1 plus c. And that's it. So this is going to conclude the first video. Like I said, the second video is going to look at exponential functions.